Hey there, Algebra 2 students. We need to talk a little bit more about graphing sine and cosine functions. So here, let's touch on the core concepts from lesson 9.4. Some of the characteristics of these graphs. The domain of each function is all real numbers. The range is from -1 to 1, right? So the minimum value is -1, the maximum value is 1. The amplitude of the graph of each function is 1/2 the difference of the maximum and the minimum values, right? So 1/2 of 1 minus -1 is 1. I also like to think of that as like the distance between the midline and the maximum, or the distance between the midline and the minimum. Each function is also periodic, which means that its graph has a repeating pattern. The shortest repeating portion of the graph is called a cycle, and the horizontal length of each cycle is called the period. The graph of each function has a period of 2 pi. And right now we're still only talking about the plane sine and cosine functions. Remember, the x-intercepts for sine of x occur when x equals 0, plus or minus pi, plus or minus 2 pi, and plus or minus 3 pi. And the x-intercepts for y equals cosine of x occur when x equals plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, etc. Before we look at some examples, I want to consider, a couple things. In finding the amplitude, when you're given an equation that's like y equals a sine of bx, or y equals a times cosine of bx, where a and b are non-zero real numbers, the amplitude is the a, right? Well, it's the absolute value of a. It's the number in front of the sine or cosine function, right? And that, remember, that tells us how tall the waves get. And the period can be found by taking 2 pi and dividing it by the absolute value of b. And remember, b is the number right in front of the x. So it's after the cosine or the sine, but right before the x. And that's how we find the period of the function. And remember, that tells us how wide the waves are, what the horizontal distance of the waves is. So of course, we're not going to waste any time in making things more complicated. So in order to graph things like y equals a times sine of b times the quantity x minus h plus k, and same thing with the cosine, right? We have to take these things apart and realize what all of these numbers and letters mean and what they do, right? So the very first thing that we want to do is identify the amplitude A. So identify how tall your waves are going to be, and figure out the period, how wide the period will be. We also need to figure out if there's a horizontal shift and or a vertical shift, k, of the graph. And then I would draw a horizontal line, y equals k, which is the midline of the graph, right? And that corresponds with your shift, your vertical shift. And then find 5 key points by translating key points of the y equals a times sine of bx, or y equals a times cosine of bx, horizontally and vertically k units. And step 4, draw the graph through the 5 translated key points. So we need to find 5 key points for each graph. So let's try this, right? Let's try this. I have my reference here, my y equals sine of x as a reference. Actually, I'm going to move that away for now. If I wanted to graph g of x equals sine of 2x, right? The amplitude is the number in front of the sine, which is 1, right? There's an invisible 1 there. And the period of the function is 2 pi divided by the 2, and so that's pi. So there's one whole cycle before we get to pi. Now normally Normally, the sine function would go through 0, 0. It would go up to 1, back down to 0, down to -1, and back to 0. But we need to condense this, right? It needs one full cycle between 0 and pi. And so it's still going to go up and then down and then back. And so we'll mark halfway between because that's when it will hit 0 again. And so we'll go all the way up to 1. We'll come down and go back by pi. So we have one full cycle by the time we get to pi, and we can do another cycle here between pi and 2 pi. And so we very carefully connect the dots and graph. But the important thing is amplitude is 1, so it goes up to 1, goes down to -1. It hasn't been shifted horizontally or vertically, right? And the period is pi. So we have one full cycle between 0 and pi. Okay, not too bad. Let's try something a little more complicated. Let's try g of x equals 4 times the sine of 2 pi x. Well, you want to look at the 4 and say, well, you want to ask what is the amplitude, right? And the amplitude is found by looking at the number in front of the sign, which is 4. So the amplitude is 4. So when I go to graph this, I want to go all the way up to 4 and all the way down to -4, and I've made my scale larger because the period of this function, to find the period of the function, we take 2 pi and divide it by the number in front of the x, which in this case is 2 pi. And so the period is 1, right? So there needs to be one full cycle by the time between 0 and 1. Now the sine function goes through the point 0, 0. There's no horizontal shift, there's no vertical shift. So it will continue to go through 0, 0. And if one period is 1, it'll be back at 0 when we get to 1. And remember with the sine function, right, it goes up and back to 0. And so halfway between 0 and 1, I'm going to put another 0. And then it's going to have to go all the way up to 4 in between here, and then all the way down to -4 there. And I'm going to connect those points with a smooth curve. And that's one cycle, right? And I could continue that, right? I can say, okay, well, 2, and it's going to go through those 2 zeros. It's going to go up to 4, down to -4, because the period is 4. I'm going to try and connect that with a smooth curve. And there we have 2 full cycles, 2 full periods of the graph of 4 sine of 2 pi x. Okay, one more. Okay, let's graph g of x equals the cosine of x plus pi over 2 minus 3. This one's a little tricky in that there is a horizontal shift and a vertical shift. But the amplitude and period are the same as the regular cosine function, right? The amplitude is 1 because there's no number in front of the cosine, so we assume that it is 1. And the number in front of the x, there is no number in front of the x, so the period is 2 pi divided by 1, which is just 2 pi, right? And the horizontal shift is pi over 2 to the left, right? Pi over 2 units to the left. And this minus 3 tells us that the vertical shift is 3 units down. So the first thing that I'm going to do is draw my vertical shift in this 3 units down. I'm going to sketch it with a dashed line. And the period is, well, the amplitude is still 1, So that means it's going to come up to the -2 and go down to -4, just like that. And so I have little guidelines, right? These are not actual lines in the graph of the sine function. They're just sort of telling me where my graph will lie. And the first thing that I did was I graphed actually a regular cosine function. So cosine starts at 0, 1, and then goes to pi over 2, 0. Nope. Yep. And then pi, -1, and then 0, and then 1 at 2 pi. And so I just graphed a regular cosine function. The regular cosine function has an amplitude of 1 and a period of 2 pi, and so that is super helpful to us as we consider then this horizontal shift, pi over 2 units to the left and down. And I'm going to get a different color to help visualize this. And so I'm going to take this point here, this 0, 1, and shift it pi over 2 units to the left. This is a pi over 2, negative pi over 2. And then it's going down 3 units. So 1, 2, 3. Let's consider this guy here. This is at actually pi over 2, and it's going to go to pi over 2 units to the left to 0, and then down 3 units. So 1, 2, 3. This point here is going to go pi over 2 units to the left and then down 3, 1, 2, 3. This guy here will go down to the left pi over 2 and then down 3, 1, 2, 3. And this guy right here will go to pi over 2 to the left and down 1, 2, 3. And I'm going to connect those dots with a smooth curve. And if I wanted to, I could continue this on further, right? And so here is our graph for g of x equals the cosine of x plus pi over 2 minus 3. Okay, this skill takes practice, if a lot of practice, if you are doing these by hand. If you are doing them with your graphing calculator and you've got a pi over 2 here, you want to make sure that your calculator is in radians before you attempt to graph these things. That could be a whole other lesson, using your graphing calculator to graph these. I hope this helps you with lesson 9.4, and I hope that you all are well. We'll see you next time.